All right, everybody, let's get started with our last in-person lecture in Engineering 102. This is it, everybody. After today, once you submit your assignments, you are done with in-person class in Engineering 102. Okay, so a couple of housekeeping items. First off, all right, if you have not yet scanned the attendance code, please do so, okay? A little bit of housekeeping items. So other than obviously this attendance, attendance is up to date. We are going to be having a virtual lecture or a pre-recorded lecture on Wednesday, and I'm just going to count everybody present for that day. So there you go there. Everything's graded and up to date, and just in case anybody was curious, that's the grade distribution in here. The only thing left is three things. The week 13 assignment, that's the stress analysis assignment, which most of you have already done. By this morning, most of you have already completed. Anybody have any questions on the stress analysis homework? That was the quiz on the plate with the hole in it. Okay. Assignment for week 14, this is the final assembly. Normally I assign those on Wednesday, but since we're pretty much covering everything today, I went ahead and assigned it today. It is going to be due next Wednesday by 5 p.m. on Blackboard. I'm not going to accept any late submissions because, I mean, that's finals week, and at some point I have to grade them and get the grades in. So that's sort of it for deadlines. Okay? Everybody good on that? Okay. All right. Just to make sure we're clear. Okay, so last Wednesday we did the in-class exercise. That in-class exercise is due Monday at 5 p.m. Today we're assembling the 4 parts that you've made in Inventor. My pre-recorded lecture is more about the assembly drawings, which they're pretty straightforward. I just have a few tips and tricks on that. And then Wednesday of finals week, we're not meeting. You're just submitting everything virtually. So again, for the due dates, week 13 assignment is due today by 5 p.m. And then the final assembly and the bonus homework, which is uploading proof that you did the course evaluation, is due by 5 p.m. on Wednesday the 24th. Now for that bonus assignment, one thing I'll mention, this was as of yesterday, I think it was, 39 of you had uploaded proof, but 44 of you have done the survey. Like, I have no idea who does the survey in the background. I just know how many people have done them. So if you're one of those 5 students that did the survey but haven't uploaded proof, like you were, I mean, that's free points in the class, so please just upload proof that you did it. Again, you can say I'm the worst professor ever, that's fine. Just as long as you upload the proof, again, that's free bonus points on top of the class. And I mean, to answer the question, I've already started grading some of these, and I do have a few people who have over a 100% homework average, so I have no problem with that, okay? Everybody good? Okay. Now, I have one other survey that I want everybody to do. It's going to be on the next slide. This is part of our assessment performance. This is our course learning outcome survey. I'm doing it virtually just to make everything easy. So basically what this is just a measure of the outcomes of the class, and mainly because, so that if maybe somebody else teaches the class or whatnot, just to give everybody some, or whoever teaches the class, some guidance on maybe some suggestions for the future. And this is one of those areas where if you have any suggestions for things to improve or things to change about the class, they would be incredibly welcome. We try and do continuous improvement, so the more you give me, it's actually the better. So this is more about just the content of the class than it is about me. But I'm going to give everybody a sec to do this while I pass out the assembly handout here in a bit. Actually, I'm doing that right now. So let me go ahead and pass this out. So if you have, go ahead and scan that while I'm passing this out. That'll give me just enough time to pass this out. All right, did everybody get 2 handouts? You should have one for the assembly and one for the homework assignment. Did everybody get both handouts? The second one? This one right here? What's that? Oh, none of you got it. I'm sorry. 1, 2, 3. Sorry. The assembly? You don't have time.
The title says wheel assembly, and the other thing we named them all what they were. They all like when we did the base plate together.
All right. Does everybody have 2 handouts? Did everybody do the survey? Okay, good. Thank you. All right. So let's go ahead and jump right in. I've got a few things to say about the assembly, and then we'll get right to it. Okay. So, come on. Okay. So our goal today is to assemble the 4 parts that we've created into this wheel assembly as shown. Again, the idea was that I walked you through 2 of them, 2 of the parts. The other 2 you needed to do on your own. And this tutorial assumes that you've already built these 4 parts. So if you haven't built them, I would just say pay attention and follow along. This tutorial assumes you've got those done. Okay. What we're going to do is take these 4 parts and put them together in one assembly. Okay. So what we'll do is we'll create 5 instances, 1 of each part with 2 of those angle brackets, and then we're basically going to use our old friend, the constraint, to put those parts where we need them to go. The constraints are going to be a little different than what we've done so far. What we're going to use are what are called axial constraints. So axial constraints are going to be used to assume or to ensure that the holes align, that the hole on the bracket aligns with the hole on the base plate. Then we're going to do surface constraints to ensure that the surfaces mate together. Okay. I want to have some notes before beginning. Okay. So when we do this assembly, okay, I'm sort of referencing everything off of the base plate, and I am assuming that your base plate was created per the directions of what we did in lecture 32. So if you created your base plate differently, like that's fine, there's no problem with that, but your final assembly is going to be at a different orientation than mine is. So I just want to mention that. As I said at the beginning of class, it's a lot easier if you place all your individual part files in a single folder. And you're going to need to do a bit of zooming and rotating and whatnot of your assembly to be able to do this. So just be aware of that. All right, this is important. I want everybody's eyes up here. Okay. For the final homework submission, you're going to need to submit a lot of different files. So it could be like 10 files depending upon how you do it. Because it could be the IPT file, the part file for every file. It could be the assembly. So I need every part file, I need the assembly, and I need every drawing. So if you have a separate PDF for every drawing, that's like 10 files. Okay? Do not submit these like one at a time. Like don't start an attempt on Blackboard to submit the part file and then submit it and then start another attempt. Like don't do 10 homework submissions, right? Start a single attempt, drag and drop all those files into a single attempt and hit submit. Otherwise, it's incredibly difficult to navigate through all of them. So you should only submit the homework once, but drag and drop all these files, okay? And for the drawings, what you're reproducing is every sheet in the final assembly drawings except the first one. I'm not going to have you reproduce the exploded, okay? So one drawing for each part, and then the assembly drawing, okay? So sheets 2 through 6. Everybody good with that? And everybody has the assembly drawings, right? Everybody has those? Okay. All right. So with that, let's go ahead and get right into it. I have Inventor open, and we're going to start knocking this out. Okay. So I have Inventor open. What I'm going to do is I'm going to create an assembly file. Okay. So I'm going to go to New, and this is our first assembly file we're creating, but it's really not all that difficult. Okay. So if you notice, up until now, we've been creating standard part files. We're going to go down below and we're going to create an assembly file, and we're just going to create a standard assembly. So a standard millimeter assembly, we'll hit create. And here's our assembly file. Let me adjust these lights to make it a little easier for y'all to see what I'm doing. Okay. And then what we're going to do is we're going to save this assembly file, and we're going to save it in the same folder as all the parts. So we're going to hit File, Save As. And we're going to go here to the desktop. I have a folder for 11 a.m., and we'll call it Wheel Assembly. Now, the way the assembly file works is you're going to be placing instances of the parts inside the assembly, okay? Now, the way that we do that is if you go up to the Assemble tab, there's an option called Place. Like, you can either place pre-built parts or create your own parts inside the assembly. Since we already built the parts, we're just going to place them. So we're going to hit Place. Then we're going to go to our folder. For me, that's 11 a.m. And inside here, you can see all the parts that I'm going to place. Now, I'm going to start off by just placing the base plate. So I'm going to click Base Plate, hit Open. And then if you notice, see what's going here on the screen? It's wanting me to put this part in the assembly. So I'm just going to click. And boom, there it is. Now the thing is, I could place hundreds of these base plates if I want, but I'm only going to place one. Okay? So all you need to do is click once and then hit Escape. If you accidentally place more than one base plate, that's okay. I'm going to show you how to delete those here in a bit. But right now, I just want you to place one base plate. Now, if you do this correctly, or if you built your base plate the same way that I did in Lecture 22, it should be to this orientation. If it's not, that just means you built it differently than I did. Okay? So I'm going to hit Escape, and then I'm going to zoom out a little bit, okay? And I'm going to place, let's see, the wheel. Now, the thing is, I'm just going to place it anywhere, okay? I am not going to try and put the wheel where it's supposed to go. In fact, I think it's easier for the purposes of assembly to purposefully place it a good bit away, anywhere it's not supposed to go, okay? So I'm going to click, I don't know, like right here, okay? Then I'm going to place a bracket. Now the bracket, what I'm going to do is I'm going to place two of them. So I'm going to click, click. So essentially what I'm doing is I'm just copying the bracket over again. And then what I'm going to do is I'm going to place the axle that I created and put that right there. Okay, so what I'll say is that your screen is probably, or may look a lot differently than mine does, especially in regards to the brackets and the axle, because you might have created them at a different orientation or a different way that I did. That's okay, we'll fix that later, okay? But what I want are 5 pieces there on the screen, one for every part, but 2 brackets, okay? Again, your bracket might be in a different orientation, that's okay, we'll fix that, okay?
It says unsupported file.
Huh. If yours says unsupported file, let's look at that a little bit later, okay? What you might need to do is open the part file and just open the part file by itself and just resave it, okay? If you're still getting that error, maybe try and go through the old versions folder. If that's still an issue, you might just have a corrupted part. You might need to redo it. My apologies. All right, everybody with me so far? Okay, all right. Now before we start piecing this thing together, the other thing that I want to do is I want to start assigning materials, okay? For this assembly, every piece in this assembly is going to be made out of cast iron, except one, and that's the axle. The axle is going to be made out of alloy steel, okay? So what I'm going to do here is I'm going to go to the Tools tab. I'm going to go to Material. Okay, let me make this a little bigger so everybody kind of see what I'm doing. All right. So I've only got one material loaded in this assembly, and that's generic. Okay, I'm going to load 2 materials. I'm going to load cast iron, or iron cast, and then I'm going to load alloy steel, or steel, alloy. Okay, and I just do that by clicking the material and then loading it up. Now, what I'm going to do, I'm not going to close this browser window. Okay, I'm actually going to try and make it a little smaller to try and show y'all what I'm going to do. So here's the material browser. What I'm going to do is click this base plate, make it iron cast. Click this wheel, make it iron cast. When I click one bracket and make it iron cast, it makes both of them iron cast, because what I'm doing is affecting the material of the part, not the instance. So it's actually changing both of them. And then I'm going to click the axle, and I'm going to make it alloy steel. Boom. And so then I'll close this. So if you do this correctly, I'm going to save this file. Actually, I'll do that later. So if you've done this correctly, you'll see that all the parts should be kind of like black, except for the axle, and it should be kind of shiny. Okay? All right? Everybody with me on this? Okay. All right. So like I said, now our next step is to start doing some constraining. Like our goal now is to quote unquote put the pieces together. Okay? Now we're going to do this using constraints. Okay? I'm going to go to the Assemble tab. Before I go too far down the rabbit hole, does anybody else have any questions about creating the instances and assigning the materials? Has everybody who's at this point been able to do that? Okay. All right. So now we're going to start putting the pieces where they belong. Now, I'm going to go ahead and tell you that your experience is probably going to be slightly different than mine, because it depends on how you built the parts. Like, for example, I'm looking at here at Mr. Cartwright's. His brackets are faced a different way than mine are. That's okay, because the way I built this, hopefully, when it's all said and done, it should all look the same for everybody, okay? So what we're going to do for each of, so we're going to start with the angle brackets. For each of these brackets, what we're going to do is place 3 constraints, okay? And these 3 constraints should affix the bracket to the base plate the same way for everybody, okay? So let me show you how this works, okay? And again, we're going to need to do a lot of rotation and a lot of moving. That's okay. So the first thing I'm going to do is I'm going to work with this bracket right here on the top, okay? And my goal is to get this bracket where it's supposed to be on the base plate. Now the way that I'm going to do that is I'm going to use 2 axial constraints and 1 surface constraint. So let me do a quick little rotation. Okay, so my first constraint are going to be axial constraints, and the idea behind the axial constraints is, notice how there's these 2 holes on the bracket. Okay, I'm going to get these 2 holes to line up with the associated holes on the base plate. So I want these 2 holes to line up with these 2 holes. And then the third constraint is going to be a surface constraint, so that the bottom of that bracket mates up with the top of that base plate. Okay? So here's how I'm going to do it. Okay? So let's do our first one. And Inventor's going to move it. That's okay. Okay? So we're going to, up here to where it says relationships, we're going to do a constraint. And we get this menu that pops up, looks something like this, and we got a couple of different options here. I'm just going to use the default option here, which is a join. And the way that constraints work, sometimes they're called parent-child constraints. The first thing that you select in Inventor is quote-unquote the child. That's the object that's being moved. And then the parent object is sort of what it's being moved to. So what I'm going to do for my first selection is I'm going to zoom in right here. And what I'm going to pick, everybody watch up here, I'm going to pick this. See how I'm picking the axis of that hole, the center of that hole? So I'm going to click this as my first, and my second is going to be this hole, okay? Now, when it does that, it, like Inventor kind of just moves the object, so depending upon how you did it, there's a chance the objects are overlapping or something like that. That's okay. I'm just going to hit apply. I'm just going to leave it like that. Now, I can go ahead and tell you right now, it's in the wrong place. And it's in the wrong place because Inventor has put the bracket inside the base plate, okay? That's not what I want, but I just want it there for now, okay? All right, so I hit apply, then I'm going to hit close just to get out of this. Now let me show you what has happened, okay? All right, and the best way of showing you what's happened is I'm going to hit escape a few times, and I'm going to just look at my assembly. If I try and grab this bracket and move it, look what's happening. It's moving it, but it's moving it in such a way that those holes are aligned, right? So I'm purposefully, so here's what I'm going to do. I'm purposefully going to, let's drag it a little bit away, okay? So So let's drag it away, make sure there's some good distance. I want some space there because I kind of want to see what I'm doing, okay? I'm going to place a second constraint to align the other hole. Now, for my assembly, that's not really necessary. For yours, dependent upon how you built your bracket, it probably is necessary, okay? So just to make sure that I can see what I'm doing, I'm gonna move my rotation to maybe another corner like that so I can see what's going on. I'm gonna constrain this axis to that axis. Okay. Now again, that didn't do anything on mine, but for yours, depending upon how your bracket was spaced, it probably did a lot. Okay. And then the last constraint I'm going to do is I want to affix the bottom of this bracket to the top of this plate. So I'm going to apply another constraint, and I'm going to go again using that rotation cube. I'm going to affix that surface to that right there and hit apply. Now it's right where it's supposed to be, okay? And it might be kind of hard to see because of the rendering that Inventor's doing. You can always go to the View tab and change the rendering from shaded to maybe shaded with edges, and now you can kind of actually see the edges a little bit better. But in this case now, the bracket is right where it's supposed to be. The two holes are aligned and the surfaces are made. That's exactly where I want it to be, okay? So now I'm gonna do the same thing with the other bracket, okay? So what am I gonna do? I'm going to align. Now you gotta make sure you're applying the right constraint to the right hole. This hole is gonna be with that one because I'm gonna turn it around. So we're going to do a constraint with this hole and that hole and hit apply. Now again, that's not where I want it. It's overlapping, right? But Inventor just moved the object the shortest distance possible so that it would enforce that constraint. So I'm going to hit escape a few times and drag that out of the way. I want that out of the way so I can actually see what's going on. Now we're going to constrain again. We're going to rotate. We're going to constrain that with that. Now it's looking a little better. Then we'll go home. We'll constrain that surface with that surface. And there we go. So now we have the two brackets affixed where they're supposed to go. Now, I'll go there real quick. We applied 3 geometric constraints, and so the bracket is actually fully constrained. You can actually tell it is, because if you look over here in the model tree, you'll see next to the brackets that the symbol changes from hollow to solid. So that means it's fully affixed to where it's supposed to go. Like, you cannot move those brackets without moving the base plate. So we're not going to do that for all the other parts, but we are for this one. Okay, I'm going to give everybody a sec to make sure they're comfortable with this. But yes, sir.
I'm not comfortable. Is there a way to improve, like, whether or not we can see it?
Yeah, that's okay. Sit okay. Now, so again, it's just moving where it needs to go. You can drag it out of the way to apply the next ones. So go ahead and do the next ones. This hole and this hole, and that surface, then it'll work. Trust me.
I did the whole constraint. This one? Go on.
Yeah, that's what mine's saying.
It won't be turning around. Mr. Dean? I'm just pissed off because you can't see the shapes. Like our
Dude, yours worked.
the first one did.
How'd you do the first one?
The same way I did the second one. But
How'd you do the first one? You do the whole first?
hole first. Can you hit the hole button? Which one's lined up?
None of them.
Neither.
None of them.
Okay. Because the reason my first one worked so good is because it was lined up already.
Well, my holes, it goes inside of it.
Yeah, that's what it does.
And then it wouldn't let me do
And
the
then-
base.
Yeah.
You know what I'm
You
saying?
have to do one hole in the bases and then the other hole.
Oh, yeah, that's awesome. Hole.
Okay.
Apply.
Apply. Cancel.
Cancel.
Constraint again.
Give me 1 sec.
No. Bottom of underneath this blade.
I'm afraid if you drain
Top of the
the
other one.
point instead of the, I think that's what it did. You gotta be careful to not hit the
Doesn't work.
point,
Yeah.
the axis of the point. Is
I
now.
don't know.
And then if I do the other hole first,
It still doesn't work.
then it's inside and I can't select the base.
Yeah. Sounds about right.
Let's look at that a little later, okay? Alright, somebody over here raise their hand.
This is difficult.
Somebody else over here.
Um,
Yes.
Because mine was rotating differently.
Yes. So I think, okay, so his game.
Okay, so I have it connected.
Oh, you didn't place it. Okay, so what you're gonna do is, so here's what you're gonna do. You're gonna place just a single constraint. So we'll place like that constraint with
Okay, see what the fuck.
that constraint. Hit apply. Then now drag it out of the way. So just place the first one, then move it, then do the next one. Yes.
Help.
What's wrong?
It's how do we get it to flip?
So you don't. What you got to do is place both constraints. Okay. So the first constraint is going to be like here with here. Okay. Then what you need to do is you need to drag it out of the way,
Yeah.
then place the other constraint. Are you talking about the view?
No, it keeps. I'm doing that, and then it says there's an error.
So when I drag it out of the way, it just grabs all of it.
I think it's because you're selecting the circle,
And not
not the
I
axis.
think that. Yeah. That was right.
Make sure when you're applying your constraints that you select the
So,
axis.
oh,
not
so
the
it's
circle.
doing
I wanna look at
the
this.
surface, like the inside of the circle.
Yeah, and not the axis of the circle. I think he's right because I definitely was doing that.
That would make sense. Yeah, I was for sure doing that. Okay.
Hey, I think you might have an
Yep.
error.
That was
That goes
See, that's there you go.
right there. Oh,
Maybe.
apply, and now, there we go.
And now the other one.
Okay.
He was hitting cancel every time.
How many?
Now,
I would place the surface.
Insane. Oh,
You gotta do the other.
alright. Do I need to do the circle first?
Other circle first.
Cancel.
I'll be over there in a sec.
You did that one. Wait, that's the right button. That's it. That was the issue, I think. Oh, you did it. That's the wrong button. Now it's right. Now you pull it down. Apply, and then it'll pull it down on the next one. That's it. Little asshole.
There we go. Oh, apply. Beautiful.
Don't you just hate when the professor's right?
And you're wrong.
Yeah, especially mainly when I'm wrong.
Which one does that go to? That sucks. There you go, there you go, there you go. Apply, cancel. Damn it. Damn it. Go do it while we do it. Press it up. Control Z, Control Z, Control Z, Control Z. Okay. Let's try again.
You did the wrong filter.
Restrain.
So what I would do is inside.
Got her done that way.
She said got her
Got
done.
her done. Apply.
And redo it
It's moving the whole thing.
for all the other faces, and then do it at the end. Does that make sense? fill it for every edge except for those. Alright. Okay. I want to address this question up here, then I kind of want to get back to the rest of the assembly. So, how's yours?
So it's below that.
Okay, alright. So, inside the wheel.
Nice. Now trying to do the axle.
Is that the next step?
The wheel, I guess. I don't know. I'm trying to do it on my own and it's difficult.
Wheel or the axle? What's the
It's probably the wheel. You probably made it in order.
What's the base plate?
Or it might be the axle. I don't know.
The back is the base plate.
Yeah, then once you do the wheel. Okay, that's what it was.
Let's do the wheel.
I can do it, yeah.
You'll have an
Can do
additional
it.
feature on your assembly list.
Yeah. Offset.
All right.
5.
If any, I think the rest of the assembly is going to go through pretty quickly. So if anybody has any issues and whatnot, still assembling, stick around and we'll take a look at it. Okay, eyes up here real quick. I want to go ahead and finish the rest of the assembly. The rest of the assembly is actually pretty easy. Okay, so let me show you how this is going to work. Okay, so the next thing that we're going to do is we're going to place the axle. Okay, so the way I'm going to do that is I'm going to use two constraints. Okay, the first constraint is an axis constraint. And so what I'm going to do is I'm going to constrain the axis of the axle, like the central axis of the axle, with the axis of one of these holes. It really doesn't matter which one because they're both parallel now, but I'm just going to constrain it to the axis. Now again, Inventor moved the part. That's okay. I'll hit apply, hit OK. And I can, just like before, I can drag this as needed. I'm going to drag it a little bit away. And then what I'm going to do is, so I want everybody to watch up here on the screen. Okay, I'm going to constrain using a surface constraint. And what I'm going to do is I'm going to constrain this sort of inner surface right here. Does everybody see that little shaded inner surface? I'm going to constrain that to where it mates with this outer lip right here. So I'm putting it into contact right there. And when you hit apply, now if I look at the front, now you can see that the axle is right where it's supposed to be. It's right flush in there. Okay? The only thing left to do is to put the wheel there. Okay? Now the wheel's a little different. Okay? Here's the assembly, right? And the wheel is thinner than the space between the brackets. Okay? Specifically, if you follow the assembly drawings, there's supposed to be a 5mm gap between the wheel and the edge of the bracket. Okay? So here's what I'm going to do. I'm going to do the same thing I just did with the axle with one slight tweak. Okay? So again, I'm going to place an axial constraint. I'm going to constrain the axis of the wheel with the axis of the axle. Okay? Hit apply. And again, I'm going to drag this out of the way. Okay? And then, now watch this. Everybody watch up here. This part's important. Okay? So I'm going to place a constraint. Now what I'm going to do is I'm going to constrain this face, that edge of the wheel. I'm going to constrain that with this. Okay? Now some of you are like, well wait, Dr. Mike, that means that it's flush up. Well, what I'm going to do is I'm going to constrain it with an offset. Okay? And that offset, here where it says 0mm, I'm going to change that to 5. And so basically what it's saying is that that's going to be in contact but separated by a distance of 5mm. I'm going to hit apply. I'm going to hit OK or hit close. And now I have an assembly. It's that simple. Okay? So I'm going to give everybody a little bit of time to work on this. Let me go around a little bit. Okay, so let me see yours.
I just wish we could have that kind of definition.
Yeah.
This is
What's that?
Is it
Alright, so what we'll do is constrain that axis
view.
with that axis. we'll apply it, but then we'll also like drag it.
Turn on shadows.
Drag it out of the way a little bit so that I can easily place the constraint with that surface to that surface so I can see it, and then it'll be
Maybe
right.
that does help.
It does
Let me
help
go
for
back
sure.
over here to
How do I
yours.
make it refine appearance?
Let me go back over here.
Where's that button at?
So yours. Whoa.
Okay, that's what I'm leaving it like that.
Default
You
light.
see it better.
Rim.
You don't need that.
But that makes it a lot easier to look at
Give a nice little name.
and understand. So just put that
I'm
shit
in the
Minecraft.
Alps. It's in the Alps.
No shit, you're in Minecraft, bro. Dark is somber.
Where is it? There it is. What is it?
You just put a wheel on the Alps.
Tranquility blue.
It's loading, it's loading.
It's loading?
It's loading.
I think this is tranquility blue.
Oh, that's what we normally use.
Wait, no, we use default light. Wait,
How is that different? It's like we
change
blue and
that.
there's a shadow.
And no, it makes it look nicer.
I bet when you start doing more
So, well, it has shadows on it. Let's make shadows off. It makes it look like his on it. It's not shiny.
I like
Default lights sucks. Look at this. How
You can't
terrible.
see anything.
It's the contrast is so much. Empty lab. Oh. What? Dude.
Just wait, go to shadows and turn off ground shadows. Yeah, it looks good. Turn on the other two. Object and ambient, and you can actually
Oh,
see.
now it looks like his.
Yeah, it looks good.
Okay. And then empty lab.
Were you paying attention when he said whenever we save it, do I hit yes to all or no to all?
No idea.
Did you pay attention there? Me neither.
Photo booth. This is crazy. There's ray tracing.
There's who, what?
Why can't I turn on ray tracing? That'd be awesome.
Brain tracing?
Red.
Oh.
It's like a we like how light.
I need to ask whether or not to save it.
It looks like this. I feel like you have a different light setting. Warm light, maybe. That's close.
This is just so shiny. But I like it has like the little white lines showing all the
Oh, but
corners and stuff. I want that because I only get that when I highlight it.
maybe if I go to Stuttgart,
Environments.
we're in Stuttgart, Germany. Look, Stuttgart, Germany.
I love how it's that cylinder.
It's just a picture of people sitting there. Plain room. Oh, sharp. See better than it could look.
I like the shadow.
If I turn on What if I do ground on it?
Okay.
It didn't change. Okay.
You got a dimension.
High quality. There it is.
Which one? Which
There
one?
it is.
Which one?
High quality.
Visual
So
presets.
now you turn on shadows.
That little
What if I turn the performance? Don't
Somebody up here raise their hand.
high quality.
Yeah, that's it.
Somebody up here raise their hand.
What's your
How about everybody
style
here? Let's
on?
take a look at it. So what I'm gonna do for yours is I'm gonna
That's a
delete all
And
of
now
the
you can actually see the shit.
Let's redo because I did that for
I
this.
wish I had this when I was doing
Yeah, it makes it so
I
much
think what's
easier.
happening
Is it
is
still
one of the
nicer
constraints
looking,
might
but
be
like-
accidental.
I'll take it.
This is good enough.
This is better than it was.
Yeah. Wait, maybe if I go to performance. Is that
One of
okay?
these.
That might be it.
No, it's still not quite there. And then I turn on.
So I'll be
There
right
it
in a
is.
second.
There it is.
Which one?
Got it.
Oh, shadows.
Oh, goodness. Man.
You turn on shadows and the lines. And then we got it. That doesn't look right.
That.
Yeah.
Window.
Like you gotta follow the
It is
instructions.
still a little shinier.
Close.
So you're
Now I can drag.
those first.
I think you actually click the point and not the axis on line because especially with all this.
They should be gone.
one more. Let's do a constraint.
I did it. It's just a
Window button right here.
Is yours flush with the outside your axle? Mine is for sure inset.
Okay, that's what I was. I think the axle's too short. Cause look from here on this side, and then if you go to this side, no, it's the same.
Yeah, mine's the same. It's just inset. What's the difference between ours?
Which?
I think what happens.
Our axles are the same. Right?
That's what I thought.
And
They are.
with all the zooming,
It should be.
because your point is to know where stuff is.
Right.
Because like the
Yours is
inside
just a little more inside. His is more
Yes.
inside.
That's not just maybe yours is too
Okay.
long.
So,
What'd you do?
so what we're gonna do is we're gonna do a
Yeah.
constraint. We're gonna
Yours
do the
looks better.
axis,
Yeah, it looks like it makes more sense.
Yeah.
supply, drag that sucker out of the way, okay?
I'm so
Back
happy that
home
we figured
here.
out how to make it look nice.
Yeah.
Okay, and then what we're gonna do
That's,
is
that
we're
was more
gonna
important than
constrain
the rest of the assignment.
this space to
There's degrees of freedom.
this space, but
Free
then
America.
Why is mine tilted?
add an offset.
What'd you do to
Watch
it?
what happens when you put an offset of 5. There you go.
There he goes. What the fuck happened?
All right, I have a couple things to show you on the drawing before we leave, so stick around for a second. I know everybody's getting antsy. Yes.
When we save, do I hit?
Yeah, hit OK up here.
Okay.
Okay. Eyes up here, because I want to make a point about a couple things. All right. All right, so look up here. So watch this, okay, because this is important. Okay, so I like my assembly. I like that it's good to go, okay? I'm going to hit the save button. Now watch what happens when I hit the save button. I get this warning message, okay? What's happening is the following. I created an assembly file and did a bunch of stuff to it, but I also did something else. I assigned materials to the part files, okay? So I didn't just change the assembly, I changed the part files as well. So Inventor is saying, whoa, if you want to save this, are you also wanting to save all the changes to the part files? Yes, right? So we'll just hit OK, okay? Or we can hit yes to all and then hit OK, all right? Because what that's doing is it's now saving the cast iron assignment to the wheel, the steel alloy assignment to the axle, and all of that. Okay, that's what that's doing. Okay? Everybody with me so far?
Yep.
Okay, I want to make one final point on something, and then I'll let you go. Okay, so if you go to the assignment that I gave you, okay, the assignment that I gave you, the one-page assignment, okay, I want to make sure that everybody is 100% crystal clear on what they need to do. Okay? Your job for this assignment is to reproduce the assembly drawings that I've given you. And the one that you do not have to reproduce is this one. Okay? You can do all of them but the exploded view. The exploded view is the one you don't have to do. Now, this is the assembly drawing. Okay? There are a couple things about the assembly drawing that are a little different from all the part views, such as the scale. This assembly drawing is at a 1/2 scale versus all the part drawings that are at a 1:1 scale. The renderings, the part views have hidden lines, or the assembly views have hidden lines. There's some text there, but there's another one that's important. That's this parts list, okay? This parts list is an interactive feature inside Inventor. I recorded a video going through all this. That is the Lecture 27 recording. That stuff right there. Is everybody with me on this? Does anybody have any questions? Because we got a few final comments. Yes. Good question? Cool. On that? Okay, I'll continue a second. Okay. Does anybody have any questions about the requirements of the assignment? All right, eyes up here. I know we're ending up. I know we're getting close. I know we're getting antsy, but eyes up here. Okay. So the final assignment. What are you turning in? You're turning in 5 drawings, the assembly and all 4 parts. You are turning in your 4 part files. You are turning in your assembly files, so you're turning in a lot of files. Only turn them in on 1 attempt on Blackboard. Do not make 10 attempts on Blackboard. Do not do that. Okay? Everybody with me on that?
Yeah.
Do we have class on Wednesday?
No.
No. Okay. Do we meet during finals week?
No.
So is this the last time we're meeting together?
Sadly.
Okay. Did everybody scan the attendance code?
Yep.
Did everybody scan the CLO survey?
Yep.
All right, I'm going to stick around a few minutes in case anybody needs anything. If that's it, guys, it has been a blast teaching you in Engineering 102. I will see you all next semester.
Yep, I got you from statics.
Do we have to put the